Welcome, everyone. Thank you very much for joining us in this webinar. My name is Marta, and my colleague is David. Hi, David.
Hello, everyone.
Today, we are going to show you how to do your steel projects with CYPE, from designing and analyzing to extracting the reports and drawings in a fast and accurate way using these tools. First of all, we want to show you our platform called BIMserver.center. This platform works as a cloud. We can share our projects with our co-workers, and you can find many of our programs in our store, including the programs we are going to use today. So the first program we're going to show you where to find is CYPE 3D. And this is for designing and analyzing steel projects. The second one is Portal Frame Generator. And this program works as an assistant of CYPE 3D. And finally, CYPE Connect. And this is for designing and analyzing complex connections using the finite element method. If you have any questions during this webinar, you can ask them through the chat, and we have some of our colleagues helping us, and they will answer your questions. And if not, if we cannot answer for any reason today, we'll answer by email. So make sure you leave us your email address, or you can write to me at marta.franca@cype.com. So now, David, can you show us these fantastic tools, please?
For sure. If you allow me, I'm going to turn off my camera so we will be able to see my screen completely full screen.
Okay.
And I'll show you around what we're going to do today.
Okay. Do you want me to switch off my camera as well?
Yes, please.
Okay. Okay.
Okay, so now you can see here that in the BIMserver.center store, in the structural analysis tab, we have CYPE Connect, CYPE 3D, and the portal frame generator. And you can download it individually, as you can see here. And today what we're going to do is that we're going to design first a frame with a portal frame generator, so we can get automatically all the loads, buckling lengths, roof purlins, side purlins, and so on. Then we will analyze this structure with CYPE 3D so we can get the reports and drawings. And of course, in CYPE 3D, we can design some basic connections, but sometimes if you want to work with custom joints, you can export all of that data to our cloud in BIMserver.center, and you will be able to continue it in CYPE Connect, as you can see here. So without further ado, let's start a new project in the portal frame generator. So let's create a new file. And you can see that we can insert either mono pitch or dual pitch frames. In this case, we're going to insert a rigid frame, dual pitch frame, but you can see that we have a wide variety of frames by default, like these kinds of trusses, rigid frames, and so on. And in this case, we're going to work with this rigid frame right here, and we're going to customize the properties for our specific project, like so. Once we are done with the physical properties of our frame, we will be able to set up the loads as well as the building code that we're going to use for the checks. Mind you that all of our software has building codes implemented from all around the world, from over 60 countries. And we're talking about things like Eurocode, British Standard, American Standards, and so on. You can see here. And this will be taken into account during the design stages for the loads, seismic analysis, wind analysis, and of course for the final checks and reports. So let's go back here to the portal frame generator, and let's set up the general data for our project. We're going to work with 5 spans, each one 5 meters apart. And we're going to have some roof coverings. You can see that we can automatically add a dead load or a live load if necessary, as well as a lateral covering with the pile weight. As we said before, we can also take into account wind loads and snow loads, and they are according to the building code that we are selecting here. If you allow me, I will use the Eurocode for this case, but as you can see, we have many different building codes from around the world, and it's just a matter of customizing the properties for your specific project. As you can see here, if you want to select the base wind speed, it's just a matter of taking a look at the different categories and maps that are linked to our building code. Okay, so we're going to work with the Eurocode with these default values right here. And once we're done, we will be able to generate our tie beams, our roof purlins, as well as our side purlins. When we generate our roof purlins, you can see here that we can work either with a series of limiting factors, like deflection limits, number of spans, or depending on the kind of analysis we're working with, we can set the purlin properties as the defining properties for our analysis, which is what we're going to do right now. We're going to select our steel type, our section series, which as you can see, we have raw steel as well as conform steel and built up sections by default. And we're going to select this section series right here. We can even customize the layout if necessary. And if you are missing any section series here, you can always create your very own, or you can keep in touch with us so we can make sure that it comes pre-installed by default. So I'm going to select this UPE series right here, simple section, accept. And as you can see, I could either design according to the section type, to the distance, the separation between the different purlins, or the steel type. And in this case, I'm going to size my purlins according to the section type. So let's click here on design, and you will see that the software will take into account the other two variables to size our purlins, that is the distance and the grade of steel that we're going to use. Let's give it a very short while, and you can see here that the first fit section in this section series is UP100, and we can see why. In this case, it's under 100% of the demand capacity ratio, so let's select it right here. You can see that we can even take a look at the ultimate state checks if necessary, and we can even export that into a PDF, HTML, Word format, and so on. And you can even see the step-by-step analysis for each different check. So once we're done, let's do the same thing, but in this case for side purlins. And of course, all the effects of these purlins will be taken into account into the analysis that we're going to do in CYPE. As Martha has said before, this is a companion tool for CYPE, so you can upload part of your work and you can automate it, as you can see here. So let's design once more. And we are almost done, as you can see here. So let's select our element like so, accept. And now we can export all of that data into a new CYPE job, which is what we're going to do right now, as you can see here. So let's export it and let's start a new job with all of this data. We can set the properties for all the frames, as you can see here, and we can work either with pin frames or fixed frames. In this case, we're going to work with fixed frames, and we are going to take into account buckling in non-sway frames for the buckling options. We can either generate just an isolated frame like this one, or we can generate the whole of our infrastructure. And we can even group them if necessary. So that way, when we edit one element, for example, in this case, from one of the central frames, each one of them is going to be updated as well. And same thing applies for the first and last frame of this span right here. So let's click accept. And you can see here that we are greeted by the main interface in CYPE. And here is where we can set up the building codes that we're going to use for concrete, cold form steel, rolled steel, timber, aluminium, and so on. We're going to set up the use category. In this case, this is a warehouse, but it also has a roof, so you can combine them as well. We're going to select the grade for the sections that we're going to use. And even if we wanted to, we could customize some of the loads that we're going to use, but you will see that all of these load cases are going to be generated automatically. So let's click accept. And here we have our frames.
Okay, David. So let me just make sure, recap a little bit. So you just use portal frame generator to create a portal. Is that right? And
Correct.
then you gave it some characteristics to that portal that you wanted, and you exported it into CYPE 3D now.
Yes.
Okay.
So that way I can have a basic geometry already set up, and I can have my loads already analyzed. So you can take a look here. I haven't added a single load of what you're seeing right here, but instead it has been generated automatically with the help of the portal frame generator.
So I see all of that, all of those loads came from the portal frame generator, this other program that we have.
Exactly.
Perfect. Thank you.
So now what we're going to do is that we are going to define, we're going to describe the rest of the nodes and bars that we are going to design here in CYPE. Because of course, now if we go to bar describe, you'll see that these bars have been grouped as we've said before, but they haven't been described yet. They do not have a physical description or so. So what we're going to do is that we're going to select them all. And for this case, we're going to work with this I series from the different material selections that we have here. As we said before, we have rolled steel, cold form steel, timber, aluminium, mass concrete even. And if we don't have the material that you're working with, you can always create your very own custom section, as you can see here, for material properties and so on. So in this case, we're going to work with rolled dies.
So we can choose the profiles we want to use, isn't it? All this is inside CYPE 3D. We can choose from the library the profiles we want to use. Is it right?
Exactly. Actually, as you can see here, we can even customize the layout data that we're going to use. So we're going to work, for example, with haunches in our sections, or with lateral plates, or with concrete slabs, or even with web openings. That's something that we can customize as well.
Fantastic.
So in this case, I'm going to work with simple sections. And mind you, that I'm working with IP80s, but the software will automatically size all the bars later for us. But let's not get ahead of ourselves. Okay, so now I'm going to add some extra bars here. So we have our full description. So for that, I'm going to add, for example, a bar right around here and here. So we can have some coherence between different frames here. I'm also going to add a main column right here, which you can see that it has also been inserted into the back frame as well.
Mm-hmm.
And I'm going to set up the fixity for these nodes as well. You can see that before we've set it up so that the different nodes here, the different meeting points with the ground are fixed nodes. But if we want to, we can even work with many of the different fixities that we have here by default. So if we want a pin connection, or if we want a roller right here, or in this case, a fixity, that's something that we can customize as well. And of course, we can add some bracing as well. So for that, we can work with tension only elements. And in this case, I'm going to add here some round bars. So I can brace at least our first frame right here. You can see that by default, it automatically releases all the movements, and it identifies it as a pin connection instead of a fixed connection. And of course, before we analyze our structure, we can generate some of the simple joints that we can design in CYPE. And of course, CYPE will do that for us automatically. So let's take a look here. Let's generate. And you can see that most of our joints have been generated and they are waiting to be sized and analyzed, which is what we're going to do right now.
Okay.
If we want, we can size our different sections. And of course, we can automatically design our connections, which is what we're going to do right now. It's going to take a short while.
Okay, so now it's analyzing the project. How will I know that my project complies with the norms I chose?
And that's a great question. As you can see here now, it's taking into account all the different checks that we have in our code of practice, in our building code. And once we're done, we'll be able to take a look at the checks that we've done internally. So for example, here you can see that all of our green bars have been sized and they...
Oh, I can see 2 in red. So is that means that they are not complying, isn't it?
Exactly. As you can see, our section series does not have any more sections that comply with the checks. And you can see here that it's because we've gone further beyond the maximum resistance that is allowed by this specific element.
Okay.
And the rest of the bars have been sized accordingly as well. If you remember, we started with an IP80, and the rest of the bars have been sized up accordingly.
Okay, automatically.
And
so
yes.
The system knew. Okay, fantastic.
And just like we did before, we can even have a full list with all the checks that we've done. So for example, let's take a look here at this bar that you pointed out that it's failing, and let's see why it's failing. We can see here that we can take a look at all the step-by-step analysis for all the different checks. And we have here, for example, the bending resistance in the Z-axis and the combined bending and axial resistance, both of them are failing, and we can see why exactly. So that way we can understand what's happening behind the scenes and we can fix our design accordingly.
And make a decision.
Exactly. That's why we get, but that's why us engineers get paid for. We get paid for taking decisions, not making drawings.
Exactly.
And just like we did before, we can export all of that if necessary into a report in PDF, Word, HTML, and so on. Let's take a look, for example, at joins that we've generated automatically as well, because we can generate drawings with all of that data as well.
Interesting.
You can see that we can customize some of these properties if necessary. Like for example, I can change the dimensions of our base plates right here, or I can customize the behavior of the stiffness, the diameters and lengths of the bolts, the anchorage, and so on. And this comes completely by default. It's something that has been done automatically. And when we are done, we can generate drawings like these ones right here.
I see. Very nice.
And when we are done, we can export all of this into a full report, which we can do right around here.
Okay.
Let's generate our 3D structure and our joints as well. You can even add title blocks as well. And we're going to generate this now in real time. And there you have it.
Very quick. That was quick.
Lightning fast, indeed. And you can see that we've generated automatically all of our details with all the necessary data that we would need to send this to our construction laborers or to our manufacturing team.
Mm-hmm.
And of course, if we want, we can print this into a PDF or we can export it into a DXF or DWG in case we would like to continue editing the finer details that we can see here.
Fantastic.
Same thing applies with the final reports. You can even have custom reports with all the necessary data, as you can see here.
Mm-hmm.
And it can be hundreds of pages long if you want to. And for example, this one has been generated now as we're speaking, and you can see that it has all the data either in tables or with the different checks with the step-by-step analysis that we've shown before.
Mm-hmm.
We are almost done here, and you can see that some of the joints, if you're working with a somewhat more complex building, like for example, this one, I've been a little bit cheeky, as you can see, I've worked behind the scenes, and I've added here a section that maybe it's not as easy for Site3D to analyze because it's a complex joint, as you can see. So it's
Mm-hmm.
missing right here. Meanwhile, the rest have been analyzed accordingly. And to solve that, what we can do is that we can export this to BIMserver.center, as you showed us before. And that way, we can continue working in parallel with other tools.
Okay, so BIMserver.center is what I explained at the beginning. Is our cloud, is our platform where we share our projects. We can share it with our coworkers, and it serves as a cloud to export and import the projects from and in our programs. So we are exporting this project from CYPE 3D, and we are going to import this project in CYPE Connect now through BIMserver.center.
So if we go to the BIMserver.center menu here, we can click on the share button if we've already linked our project. If not, we would have to go here, click on link, and we can select an existing project, or we can create a new one, as you can see here. And the synchronizer will take care of this in the background. So let's export this one right here. And you can see that we're going to export the forces so we can design our connections as well. So there's no
That
need to
is
model
a
things at
very
once.
important point in this presentation. We are exporting all the loads into the other program from CYPE 3D into CYPE Connect. And that's very important because no one else has this characteristic. So we are unique in this sense.
So if we click here on share, we will be able to generate an AFC file, which will be read later by CYPE Connect. You can even generate a 3D model with all of this data, and we can share this with our colleagues if we want. We can even work with VR and AR tools if necessary, so that way you can use either the free 3D viewer in your browser, or if you have a smartphone or a set of VR glasses, you will be able to see your project with a new level of understanding. So let's continue here in CYPE Connect. And I'm going to create a new project so we can reuse all the data that we have uploaded before. Let's click accept. Let's select the project that I was talking about before. And then we will be able to import our IFC file that we've generated previously with CYPE, as you can see here. Once it has finished importing all of this data, we will be able to fine-tune the details for each specific section, as you can see here. So in case you want to customize any of the sections that you've worked with previously, you can do that here as well. You can see that by default, we support cold form steel as well as rolled steel sections, and we have a wide range of section series to choose from. Of course, you can use CYPE Connect to design steel joints like the ones that we're going to design now, but you can even use it to design timber connections as well as steel to timber and steel to concrete joints.
Exactly.
Now you can see that we have imported our structure from CYPE.
In here you can see in the center, so that's CYPE 3D, but if you go to CYPE Connect, sorry, David.
Oh, thank you.
You can see the project in the big part of, so on the right-hand side, that's the project we imported from CYPE 3D. And on the left, you can see the list of connections that you can create or design and analyze.
Before
And
we
there,
get into that,
the little window is the connection you are choosing from the list.
before we can design anything, first of all, we need to set up the building code that we're going to use, of course. And you can see here that we have different building standards from around the world, including the Eurocode, as well as the British standards, American standards, and so on. And same thing applies for timber and concrete if necessary. We can even fine-tune the safety coefficients if necessary. And we can even set the limiting stiffness factor if we're going to analyze the rotational stiffness later. And once we're done, we will be able to select the joint that we want to design. In this case, I'm going to design this one right here.
Okay.
And you can see that to do this, we work with a series of operations right here. Things like adding plates, bolts, welds, openings, anchors, stiffness, and so on. And for that, what we're going to do is that we're going to first solve all of these clashes that we are having right here. You can see that our sections right now come out as is, and they are clashing. So let's solve the clash between V2 and V3 with an end plate. So let's add an end plate here, and we're going to select section V2, and we're going to join it to section V3 on its bottom flange, like so. And let's change here the physical properties of our plate, like so. We can change the overhangs, thickness, and we can even automatically add some welds on the flanges and on webs. Simple as. Of course, when we're working with welds, we can customize the properties of each weld. So if we want to only weld one side, for example, we can select which one we're going to weld as well. You can change the through witness if necessary. And you can see that it automatically updates in real time. And of course, all of this data is going to be taken into account when we do the final analysis. So let's continue here with more clashes that we are seeing. So for example, section V1 is clashing against section V3. So let's adjust this section right here. And let's make it flush with the nearest base of section V3. So now we can work very comfortably.
Mhm.
The next step would be, for example, soldering section V3 to section V2 through the front plate. So let's add that weld as well. And we are going to weld section V3 to plate front 1. And in this case, it's going to be a lap weld, as you can see. So let's switch the other way around, sorry. And you can see that we can even have initial and final displacements. We can see if it's going to be only on one edge or all given edges. And of course, when we are done, we can continue with the rest of the adjustments that we're going to have. So for example, let's add a trim to section V1 because I would like to design here not a fixity, but instead we're going to have a pinned connection there. So let's trim section V1 on its top part. You can have either a stride, a core radius, or a drill, like so. I'm going to copy it and do the same on the bottom. And we can customize the properties for our coordinate radius as well as the X and Y sections that we're going to have it here.
Okay,
So
that's very easy.
let's add here the length we're going to have for our plate because we're going to add a plate here later.
If anyone from our audience is thinking, oh, this is overwhelming, if I don't know this program, we have many videos in our website to help you start using the program. So, and we have many videos in YouTube as well. But if you go to our website, you'll find many videos to help you starting with CYPE Connect.
And to not bore you anymore, I will show you the final results so you can get an idea of what we're doing. So as you can see here, I've added the chord radius on the top and bottom parts of section V1. I've added this plate right here, which can either be completely freely detached of all the different elements that we have here, or it can be either perpendicular or attached to any of the sides of our section. And of course, we can also have bolts like these ones, which we can either add manually or we can add them automatically with the help of our bolt generator right here. And last but not least, I'm going to add this weld right here so we can weld plate 1 to section V2 right around here. So now that we are done, we can continue with the analysis.
Okay.
So we first have to generate the loads from the BIM model. And as you can see, we will be able to reuse all the data that we generated previously. So if we go to load cases, you can see here that we are using all the load cases that we have set up before here in Site3D. Let me show you here in the general data. And of course, we're going to take into account all the different load combinations according to the building code that we're working with. We can even customize the distance between the application point of the forces and the theoretical node, as you can see here. And of course, we can customize one by one all the different values for all of these stresses, as well as the different acting load cases, and the properties for the rotational stiffness as well. So we're going to analyze our joint right here, and let's give it a short while so we can get our final results.
So how does CYPE Connect analyze the elements, David?
As you can see here, we're working with OpenSys, which is a finite element analysis engine developed by the University of Berkeley, California. And what we're going to do is that we're going to turn all of our discrete elements right here into simplified finite elements. Like for example, we can turn the different sections into plates, shells that is. Plates can also be simplified into shells as well. And things like, for example, the wells that we're seeing right here can be simplified into point elements, and
Okay.
the bolts that we've added before will be modeled into spring elements as well.
Uh-huh.
So let's give it a short while, and once this is done, let's take a look at the final reports.
Okay.
Okay, so you can see here that we've finished with our analysis, and we can interpret the results visually, as you can see here. So we can take a look at the maximum capacity ratio for each element, or we can take a look at all the elements that we've simplified before here into shells. And we can even take a look at the deform shape of each element. Well, maybe not so rough, but you get the idea, right? And of course, this is a finite element analysis, what we're doing, but we also take into account some of the components-based analysis that we normally take into account for disposition. So we can see here that sections do not have any kind of error whatsoever. Same thing applies for plates, and we can take a look at some of the checks that we have for the different plates right here. But for the balls, you can see that we have some errors. Like, for example, we can take a look here that the demand capacity ratio has been exceeded. And it's something that it's pretty easy to identify here with the maximum demand capacity ratio. And besides that, we can see that some of the layouts that we have for the holes, they are not complying as well, and we can see why here. So if we need to fix this, we can easily interpret the results and act accordingly. And of course, when we finish with all of that, we can export all of this data into reports like summaries. So you can have a basic overview of what's happening in our joint right here. Or we can create a complete report with all the checks that we've done accordingly. And just like we did before, we can export this into a PDF, HTML, Word, and so on.
David, I have a question. Can we create drawings from this connection?
Sure. As you can see here, if we switch to the Sheets tab, you'll see that we can automatically generate drawings like these ones. And to do that, we only need to add a new sheet like this one. And we can insert some predefined views, so we can populate our drawing with elevations, sections, floor plans, and so on. And we can customize this so we can have something like this. We can populate our drawing as well with elements like, for example, dimensions, which are automatically read off of the BIM model, as you can see here.
Okay.
And of course, if necessary, we can also add smart tags like this one right here, so we can read the data off of the BIM model. And in case we change anything from our model, the tags will be updated as well.
Okay.
Let's say that we are missing one of these sections right here. No problem. You can generate a section automatically as well. So we're going to do that here, like so.
Very nice.
And just like we did before, we can populate our drawing with all of these drawing elements. It's these automatic tags, dimensions, and so on.
I have another question for you.
Mm-hmm.
So if we use one connection like very often, how can do I need to create them every time?
Well, in this case, it's just a one-time investment. You only have to design your joint once, and you can create a library with all the different joints that you're going to use. So in this
Okay.
case, I'm going to save this drawing right here. And if we go to the Model tab, you may have noticed that we have the library ribbon here. So we
That's
can
this.
have a connections library, like this one that we've generated previously. And
Okay.
we can export this one if we wanted to. And it doesn't matter if our joints don't have the exact same elements, the exact same joints, because what we're going to reuse is the operations that we've designed previously. So that way, if we want to apply this very same joint to these sections that we're seeing right here, we can get rid of all of this, and you will see that we can map one-to-one all the different operations that we've done. So let me delete this right here, and let me import the joint that we've exported before. And you can see that I only need to do this once, and I can have a very wide library that will be able to import and export both inside our model as well as through different models.
Okay. What about the drawing? Do I save the drawing as well as the connection?
Of course,
Okay.
let's give it a short while. And you can see that the drawings have been preserved as well.
Okay. Very nice. What if, sorry for the question again, but what if I change something in the connection? Will it change in the drawing as well?
Well,
Like a
of course,
measurement?
all of this data is being read off of the BIM model that we're working with. So if I change any of the properties of these elements, like for example, let's say that we wanted to change the size of this plate right here, I can go to the model here and I can change the physical properties, the geometry of my plate, like so. And if I go back to the drawings, you should see this in action. Indeed, you can see here that both the smart
It's
tag as well as the drawing has changed.
very nice. No more questions for now
And
from
of
me.
course, when you're done, you can always export this into a PDF as well, which is what I'm going to do right now.
That's very
And
important.
it's going to be fully vectorized.
Okay.
You can see that this is going to take a very short while. And once it's done, I can take a look at my PDF file with all the data.
Mm-hmm. And you can create your box with your details for your company and everything and save that and like creating a template for your drawings.
Exactly. You can see here that we have that templates ribbon. And in the templates ribbon, you can manage your own library of templates. So in case you already have a template that you have generated with CYPE Connect, or even with OpenBIM Layout, which is our free tool for coordinated drawings based off of IFC files, you can reuse that data as well. So you can have your frame, your text, and so on all around your drawings.
Okay. So is there anything else you want to show us today?
Well, we can have a very short recap to see what we've done today. And,
Yes, I think it's a
and
good
sure,
idea.
if
Yeah.
we have any more questions from our colleagues back home, we will make sure to answer them on the chat as well as keeping in touch later through our technical support department and through Marta as well. So
Yeah.
feel free to ask as many questions as you want.
Yes. And you can send us or send me an email if you want to marta.franca@cype.com or through LinkedIn if you want. You can find me in LinkedIn and connect that way with me, and I'll be happy to help you.
Okay, so as a quick recap, we've installed from BIMserver.center all the tools that we've used today. which are
Yes,
the
that's one
portal
thing
frame
that I wanted to
generator.
say. Sorry, David. I wanted to say that you can use our tools as like in an evaluation mode. So you can download them. You cannot do real projects, but you can test all the software that you can see there. And if you want to just create an account in BIMserver.center, which is free, do it, and then you'll have access to our platform and you'll be able to download all these programs. So now, sorry, carry on.
Oh, thank you. So if you want to try it out, you can create your free account today. And if you go to the structural analysis tab, you will be able to download all of the tools that we've used today, so you can try it on your own. You could start with the portal frame generator, so you can upload part of that analysis for frame buildings like the warehouse that we designed today. And then you can continue with CYPE, so you can set up the properties of all the elements that you're going to analyze. And of course, you can carry out the analysis with all the checks according to the building code that you're using, as well as the reports and drawings showing all of that data. And when you're done, if you want to bring this up one level further, you can continue with CYPE Connect, exporting all of your data to BIMserver.center. And that way, you will be able to reuse all of this data so you can design your custom joints like the ones that we've designed today. And when you're done designing and analyzing, you will be able to generate reports and drawings like the ones that we've created today.
Yeah, exactly. So can you go back to the BIMserver.center website 1 second, please?
Sure.
If you go to the CYPE Connect website, the page, yeah. If in this page, you can go to our website, the CYPE Connect page, and you can see there's a button for learning resources. As I mentioned earlier, we have a quick start guide, which is that will help you to start using CYPE Connect if you want to test it. So you have a few lessons, there's a few videos for you to learn how to use the basics.
And of course, what we've shown you today is just a teaser of what you can do on your own. So if you are interested, you can use our free learning tools, like what you're seeing right here in your resources menu. And
Yeah,
of course, if you have any questions, feel free to keep in touch with us at the Technical Support Department.
exactly. Okay, so I think that's enough for today. Otherwise, it's too much information for everyone. So I just want to thank you again for being there with us. And if you have, as we said already, if you have any queries, please contact us. So we'll say goodbye now and have a good day. Bye-bye.
Thank you very much. See you next time.